Hello and welcome back. In the previous videos, you learned something about arguments and how to visualize them using MindMap. From here on, we'll dive a little deeper in the theory behind arguments, the proper use of logic, and common mistakes in reasoning. If you can identify common flaws, you'll have very important tools to be an effective critical thinker. First, about logic. To understand logic and reasoning a little bit deeper, it's important to start with looking at the way our language works. Hopefully, you'll find out that logic is something you use every day and that these things are rather obvious. Still, even if people use logic correctly themselves, it might still be hard to point out the flaws in the reasoning of other people. And that's what we're looking for in this video series. Let's take a look at logic in language. As we've already seen, we need statements and arguments, so sentences that are true or false. But these come in all shapes and sizes. Compare the next two sentences. Grass is green, and if grass is green and the sun is shining, then life is good, or else I should stop complaining. Both are sentences, but the first one is pretty simple and straightforward, while the second one is more complex and harder to say if it is true or false. To understand the difference between the two sentences, we need to have some knowledge of logical connectives. In logic, we distinguish between atomic sentences and molecular sentences. You might be familiar with atoms and molecules from chemistry, and the only commonality between logic and chemistry is that atoms are used as building blocks for molecules. So a molecule is always more complex than an atom, and it can be broken down into parts. That principle also applies to sentences in logic. Atomic is Latin for indivisible, means you have a sentence that is true or false, and you cannot break it down into simpler sentences. A molecular sentence is a more complex sentence that has simpler sentences as its building blocks. Molecular sentences can also be true or false under certain conditions. Consider the two sentences we saw earlier as examples. Grass is green is an atomic sentence. If you try to break it down further, you're just left with the individual words, and it's no longer a complete sentence. So if you break it down further, its parts cannot be true or false anymore, since it stops being a sentence. But what about the other sentence? If grass is green and the sun is shining, then life is good, or else I should stop complaining. We can break this down into these sentences. Grass is green and the sun is shining, life is good, or else I should stop complaining. The words if and then were included in the original sentence, but they are not included in the two sentences that are its building blocks. These words connected the two sentences together. If then is a very common way to connect two simpler sentences together into a new sentence. The sentences with if then are called implications. These implications are indispensable to do reasoning, and we use them all the time to describe, for example, causal relations, so relations about cause and effect. Here are some examples of implications, or if you're more precise, material implications. I'll explain that later on. If you don't depart on time, then you will be late. If you drop a glass, then it breaks. If you are not for us, then you are against us. If you do not study, then you will not pass the test. The implications that are useful in arguments are the implications that are made up of two statements. That's what we call a material implication. We usually just say implication as shorthand, or if-then sentence if we seek to avoid technical terms. Everybody will know what you're talking about. As I said earlier, these sentences can be used to describe cause and effect, but it's not necessarily so. And in logic, the only thing that we say is that if the first sentence is true, then the second sentence is also true. So what about the parts of an implication? This is crucial if you will do actual reasoning with implications. The part immediately following the if is what is called the antecedent, which is Latin for that which goes before. The resulting sentence, of which it is implied that it will also be true, given the truth of the antecedent, is called the consequent. That is Latin for that which follows. Unfortunately, the antecedent does not always come first in a sentence, as you can see in the sentence, glass breaks if you drop it. then the consequent will be the first part in the sentence, and the antecedent will be the last part of the sentence. But how do you establish if an implication is true? The short answer is we can calculate the truth from the truth of its parts, the antecedent and the consequent. That can be a bit tricky, so let's consider an example to illuminate the difficulty. If my house is on fire, then it is damaged. This statement does not say anything about the actual state of the house right now. I repeat myself, this statement says nothing about the actual state of the house right now. That's very important to remember. There's no claim here about the house being on fire, nor is there a claim being made about the house being damaged. It doesn't even claim that the person actually owns a house. It only states that if the antecedent is true, then the consequent must be true as well. You could even say that if this sentence was uttered by a homeless man, it would still be true. If you can come up with a counterexample in which the antecedent is true but the consequent is false, then you have demonstrated that the implication as a whole is false. We can therefore say that the antecedent as described here in the example is true. It's always true that if the house is on fire, that there will also be damage. Maybe minor damage, maybe hardly worth repairing, but the house will be, without exception, be in a worse condition than it was before. If we flip the antecedent and consequent, then you will see that the implication will be false, because we can come up with counterexamples. If my house is damaged, then it is on fire. Suppose the antecedent is true. There is some damage to your house. It needs repair. Does it always follow that the house is on fire? No, not at all. Here we have a picture of a counterexample. The house could be damaged from excess water. It could be damaged from a tornado, as is the case here. Maybe an airplane fell through your roof. All these cases would result in damage, but not necessarily in a house on fire. So this material implication is false. Even in the case you can come up with an example in which both the consequent and the antecedent are true, the implication is still false, because it's not always the case that the antecedent is true, the consequent is true as well. So if a house is damaged once from a fire, that does not mean you can attribute all damage of all houses ever to fire. But more about that later on when we'll discuss logical fallacies. To summarize, this would be a false implication because the antecedent could be true while at the same time the consequent is false. A special last case is when you think the antecedent will never be true. If a certain statement is so ridiculous that it could never be true, then people sometimes express that in an implication like this. If Donald Trump wins in the 2016 presidential elections, then I will move to Canada. It's easy to say that if you believe that Donald Trump will never win. You might just as well say, if Donald Trump is elected president in 2016, I will eat my shoe. It's fairly easy to ascribe to the truth of a statement like this, because if your expectations are correct and Donald Trump does not win the presidency, then you will never have to move abroad or eat your shoe. But since Trump did win, a lot of celebrities were pointed out and mocked for their lack of following up on their promises, as you can see in this article from The Guardian. So, if you think the antecedent will never be true, feel free to make ridiculous sounding implications. They might very well be true, even if they're completely useless, like this one. If circles are squares, then the moon is made from green cheese. I'd be more than happy to say that this material implication is true, for I know it's logically impossible for the antecedent to be true. Circles will never be squares. But making false promises that depend on future election results is not very smart, and people will call you out for it, especially if you're famous. Truth matters to people. But since circles will never be squares, I'm never committed to the conclusion that the moon is made from green cheese, and I might just as well say that this implication is true, even if it's completely useless. So, a material implication is the connection of two statements using if and then. Remember, statement is a sentence that can be true or false. An implication can also include a command, question, or exclamation, but these sentences are neither true nor false, so be mindful of that. These are not material implications. If my son arrives, can you please let me know? That's an implication with a question. If you cannot behave, then get out of my classroom. Implication with a command. Check out my very first video in this playlist if you don't know the difference between a statement, question, exclamation, or a command. So we know about our first logical connective, the material implication. We will learn about two more logical connectives now. Without these logical connectives, it is impossible to argue for or against beliefs, ideas, positions, etc., etc. That's why they're so important. We're going back to the two sentences that remained after we broke down our complicated material implication. So we were left with grass is green and the sun is shining, life is good or else I should stop complaining, after we took the if and then logical connective away from the sentence. Are these atomic sentences? Can we break them down further in such a way that their parts can still be true or false? Yes, the sentence grass is green and the sun is shining can be broken down into two sentences. Grass is green, the sun is shining. Both can still be true or false. And the word that is missing now is the word and. This is our next logical connective. A sentence that contains the word and is called a conjunction. Suppose that grass is green is a true sentence, but the sun is shining is false. What would that say about the sentence grass is green and the sun is shining? Is that sentence true or false? In logic, we say it's false. Both sentences, called conjuncts, have to be true in order for the conjunction to be true. So here we see the first conjunct is true, the second conjunct is false, and therefore the conjunction of the two sentences, the whole sentence, is false. And as I said earlier, the two parts of the sentence, one atomic sentence and the other atomic sentence that together form the molecular sentence, are called conjuncts. And there are two conjuncts in this conjunction. So conjunctions are very common. Take this example from the recent political campaigns in America. Bernie Sanders was one of the candidates for president on the Democratic side. He said Donald Trump is a racist, sexist, homophobe, xenophobe, and religious bigot. This is a conjunction of the atomic sentences. Trump is a racist, Trump is a sexist, Trump is a homophobe, Trump is a xenophobe, and Trump is a religious bigot. If we were to write it in its full logical form, then we would have to say Trump is a racist, and Trump is a sexist, and Trump is a homophobe, and Trump is a xenophobe, and Trump is a religious bigot. Nobody talks like that, of course, and therefore we use shorthand. But nevertheless, a critical thinker would want to see evidence for all 5 separate accusations before agreeing with Bernie's assertion. These 5 sentences all have to be true in order for this Bernie Sanders quote to be true from a logical perspective. So just to return the favor, Donald Trump, of course, also said things about Bernie Sanders, that Bernie is a socialist and communist, and socialism wrecks nations and destroys societies. You can break them down first in the middle and say there are 2 sentences here. Bernie is a socialist and communist, and socialism wrecks nations and destroys societies. And you can break them down further into the atomic sentences. Bernie is a socialist, Bernie is a communist, socialism wrecks nations, socialism destroys societies. These are 4 conjuncts that all have to be true for Donald Trump's conjunction to be true. And a critical thinker, of course, would want to see some evidence for all 4 conjuncts. So now we know about the conjunction and the material implication. The last logical connective we'll learn about today is the disjunction. The last sentence we had left is life is good or I should stop complaining. And we can cut this down into 2 true or false statements. Life is good, I should stop complaining. And the word that is missing now is or. So a sentence that joins together 2 statements using the word or is called a disjunction. At the disjunction, you call the 2 parts of the sentences disjuncts, and a disjunction as a whole is true if at least one of its disjuncts is true. Bachelors are married or circles are squares is thus a false disjunction since neither disjunct is true. Here's an example from reality about the use of a disjunction. Kids in the Dutch school are required to wear masks now, and sometimes kids are encouraged in a not so constructive way. So, uh, some kids heard that either you wear a mask or you want your grandmother to get sick. And students at this school will probably deny both disjuncts. Therefore, it's probably a false dilemma, but well, maybe it's a true disjunction, and maybe if you don't wear a mask, your grandmother will get sick. So, to conclude, the simplest building blocks we have for arguments are atomic sentences that are true or false. In order to do reasoning, we need molecular sentences too. So, different ways to connect one atomic sentence to another. The logical connectives we learned about are the implication using if and then, the conjunction using and the disjunction using or. All right, that's it for today. Next time, I'll teach you some actual rules of inference to do some real reasoning.